it as a standard, people do like totally crazy implementations. And monitoring the target, I mentioned this in the beginning, right? If you have some sort of either agent that you can run on the device, that's the best way to do it. Usually testing networking devices, you don't know what, you don't have access to the source code. So that's another thing. People refer to fuzzing. You're going to find in books, websites, whatever. You're going to find that people say it's black box testing, which I kind of disagree, or it could be. You could just throw bad packets at some device. But gray box testing, which is another gray area there, right? If you have some intent, if you know something about the device you're testing, the better chance is that you're going to break and be successful in whatever you're trying to do. And for servers and stuff like that, it's easier. You just run the agent, and fairly enough. Usually with networking devices, I think one of the best ways is just try to use a console or SSH telnet and just run some commands that you happen to know that you're going to be looking for some faults. Remember, fuzzing also is not only about breaking a device. It could cause some delays, like CPU spikes. So valid traffic is affected by the bad packets you're sending there. So what tools do we have? I just put a really, really tiny summary here of the tools. There are so many, but these are mostly the frameworks, but the first one, all of them but the first one. But what are the tools that you can use to fuzz? Number one is yourself. It's a pain in the butt, but you can do it. You just do, like, you change the packets manually, you send one at a time. The cool thing is that the reproducibility is going to be good, because hopefully you know what you're doing. But again, it's really slow, it's tedious, but again, you can do that. If you reverse engineer some code of something and you want to just look for registers and stuff like that, you can do it. Tedious, but could be really effective. Just real quick about all the tools that are out here. Spike is the most, I guess, the most famous one. Was written by Dave Vitale from Immunity Security. And he wrote this in C. And the cool thing about this is block-based. What does that mean? There's a link at the end as well for that. But block-based is an easy way to define, let's say, objects. How to, so it's, what's the word that I'm looking for? Not expendable, but forgot now. Bad English. Anyways, it's easy to, you don't have to, what's the word? You have to, not to kind of expand, right? You want to, it's easy to, okay, I'll remember later. But it's easy to implement. You don't have to write the same thing again. You're just like looking for, you do a structured based, and you're saying this protocol is really similar to this protocol, or you're looking for this, you just define a block. You don't have to do like static stuff. There's more dynamic stuff. Protos, that was created in Finland. It's written in Java. Today it became a product. Actually, it's the next slide, it's the commercial product. But Protos pretty much became a product, and they have so many fuzzers. They're like, it's pretty cool. But again, it's not really a well, it's kind of a framework, but they do like really specific for protocols. So they have some good stuff there. You can still use Protos, download and stuff. Peach was written in Python, and I like the quote that you get from the README file, that it was written while drinking beer at PH Neutral a few years ago. So it's a really good also framework, fuzzing framework. Anti-parser is another one. It's not only a fuzzer, it's a fault injection too. So again, all of these are still really usable and downloadable. Defuzz, another one. I didn't get too much information about defuzz, just Google for it. And lastly, Sully is I guess the newest one, like on the public domain. And it was written by the same guys who wrote the fuzzing book, the guys from Tipping Point, and who else? Spy Dynamics, and some other guy. It brings something like, they did a really good study before writing, like, before releasing Sully. So they bring to the table some really cool stuff. One of them is parallel fuzzing. which you can do with other fuzzers, but you can like either have to use two machines doing the same thing. Just try to break something faster. So parallel fuzzing is one cool thing. And Legos is the definition they use for objects. So you actually create objects that you can use on different fuzzing. So you're kind of creating templates for stuff that you want to do for whatever protocol. That helps. Commercial stuff, these are the people who make commercial protocol fuzzers. Of course, I'm not going to talk about my company or my competition, but here's a list of whomever do commercial protocol fuzzers. Getting creative, right? So how do we try to break stuff faster and more effective? That's the goal, right? Fuzzing is just like we were talking last night over dinner about scanning, using some sort of scanning, protocol scanning tool. Sometimes it takes forever. And, well, it's okay, but if you can do something faster, right? If you're a consulting company and you're charging your customer per hour, of course you're making more money if whatever tool takes forever to run. But at the same time, you kind of could feel a little bad that you're just sitting there waiting for some tool to run. So if you get creative to make things faster and more effective, that would help. So what people usually do, right? Different fuzzing tools at the same time. Again, the trade-off with that is if you break something, cool, but again, you're adding some like more variables to the thing. So which one broke what? So monitoring is really important. Using the same fuzzing tool, doing like parallel fuzzing. So you're fuzzing one protocol, you can use Sully to do that, or if you have like some device that has two NIC cards, you can send to break one protocol and then another protocol. Depending on the application, some applications might use more than one protocol, right? Use TCP for something and UDP for some sort of heartbeat. So that would be a really useful way to try to break both at the same time. What usually people do is use a traffic generator, any type of traffic generator to send valid packets, because that's how usually people like quality assurance people, that's what they know, right? They test performance and features. So if it doesn't, they're really used to this. So if it doesn't work, that means there's a bug and somebody has to fix it. When you send bad stuff, it could lead to a vulnerability. That would be a bad thing. So people are still trying to like getting to understand this. But sometimes you send just like bad packets at one device, nothing happens. Now, if you send lots of traffic and then you start sending bad packets, that could lead to a problem. So getting creative is really important. Again, fuzzing, writing tools and stuff is already a really creative task. But implementing, the more creative you are, the better. And of course, you can integrate with Nmap or any other port scanning thing just to make sure that you're testing, you're fuzzing, whatever protocols are there. I'm not going to be testing some device for BGP if it doesn't support or if it's not running BGP in some water. Okay. And depending on what you're testing, if you could try to use an agent, that would be better. For servers, Windows, Linux, whatever, that's easier. For any embedded device or for any networking device, that's kind of hard, but doable, as I mentioned, how FX did some stuff a few years ago with Cisco. And again, use any tools available. Sometimes a tool that doesn't do much, when you integrate with everything, it's going to help you a lot. So let's talk about packets. Really can't see anything, huh? So what was this? This really sucks. I'm sorry. This is a packet capture that I took when I was doing dumb fuzzing. But that was just doing the /dev/u random, sending stuff through netcat to some port on, in this case, DNS. In this case, I was sending DNS over TCP, not the regular UDP stuff. So these are the packets from the source, the attacker, to the target. And if you can look here, like these are, again, these are totally random packets. But for example here, zone change notification. Some random packet actually is understood as a zone change, right? Some other packets, or most of them, are unknown operation or something like that. In this case, I didn't break the DNS system, but I didn't run that for that long. On the other hand, here's the opposite, right? These are the reverse flows. So most of the stuff here, what does it say? Unknown operation, for example. The other ones, they think they're like chop packets, like fragmented packets. So again, some stuff it thinks it's real, some stuff it doesn't think it's valid. That's how the device should behave. Should, depending on the protocol, should just drop it, or should it send a message back saying, well, I don't know what this is. Another example here, when the device receives something, this is an example where the device receives something bad. It's a little better. No, the color didn't help. But every time the device receives a bad packet, it's actually resetting the connection, which, again, TCP, that could be a good way to handle this. Device didn't break either. Now, this would be, actually, we skip this one. I can do that one. This is the smart way to do it. In this case, it's a D8CP packet. It breaks, makes one of the devices that I tested totally break. This is one packet. I sent one packet to the device. It's a D8CP Discover packet, and it has just some bad stuff here. What was that? The option, you have a length. You're saying the length has 255. The device receives that and says, whoop, I don't know what this is, and breaks, instead of just dropping the packet. Same thing with the other example. This is a little better. You're sending like bad value, like this is kind of an overflow, I think. Option value, yeah. You're sending like 255 bytes on a, you're doing an overflow, so the device is not expecting that. So again, receives the packet, instead of simply dropping, it just breaks, totally breaks. So comparing a little bit fuzzing with what's happening with the security community, right? If you saw the talks yesterday, especially the keynotes, this is being addressed. Who saw the keynote today from Emmanuel, by the way? Nobody? Oh, okay, a few. Not the only one hungover, I guess. So, yeah, I think people are more like the state of the security community is kind of in a weird state, right? People, they're like people that just don't care about stuff anymore, people that just don't want to break stuff anymore. Like you have the total opposites of everything. So, and you have people that are just put into the spot like, oh, you are an IT guy, and now you take care of security. And the guy buys a firewall, and he thinks he's okay. So there's this whole concept, and it actually is a really good concept when well implemented, is what the security in depth, that is like adding more layers of security to make something more secure. In theory, that works really well, or when it's well done, it works really well. But when it's not really well done, or people don't understand, they just start buying boxes and putting boxes in the middle of something. So you have an application here, and you have like, I don't know, the internet here. And you keep adding boxes, say, the more boxes, the more stuff I put in the middle, the better. Not always, right? If you break something in the middle, if it's a critical infrastructure thing, and we're going to get to that in another bullet or so. If you break something in the middle, that's kind of a DOS attack. If you send a packet like that one packet that breaks one device, for me, that's a DOS attack. So people relate DOS attacks with sometimes flooding. Just keep in mind that it's not always the case. As I mentioned before, so again, think about fuzzing as a tool to help you like do robustness. You can add as many boxes as you want in the middle. Just make sure the boxes are robust. They can handle whatever they're supposed to. Don't hide like problems, right? You say, yeah, that device crashes when I send an ICMP packet, but actually that's going to be behind a firewall, so that's okay. Think about that. That's not a really good approach for security. As mentioned before, security is mostly done based on known attacks, of course. That's easier. Not totally easy to do it, right? If you take care of firewalls and stuff, or IDSs and stuff like that. Make sure the IDSs and everything has the right signatures. But if you're using like V8